Today I am pleased to introduce you a very ambitious project. The name is RECODE and has received funding from the European Union in the Horizon 2020 contest. Today I present you the very first results of an investigation about the mechanical properties of cement mortar with the addition of calcium carbonate nanoparticles in the cement matrix. RECODE is a project that aims to enable a circular economy in order to reduce the CO2 emission of the cement plant factory. And as you can see, the full title of project is very interesting. Is recycling carbon dioxide in cement industry to produce added value additives, a step towards a CO2 circular economy. The duration is set on 4 years, and in this case, the contribution of Polytechnic of Turin in terms of study and evaluation of mechanical properties began a few months ago. As you can see, the coordination is done by Italy, and we have a lot of important industrial partner, for example, in research institution, some important European university like the University of Groningen or the Karlsruhe Technology Institute. And we have the collaboration of the first and the final user, that is the cement plant industries, that is Titan in Greece. The concept of a RECODE project is very simple. The gases in the cement manufacturing plants will be captured and purified with a low energy engineering dissolution, in particular by means the electrochemistry and controlled precipitation, in order to capture and reuse the CO2 emission in forms of valuable chemicals products, in order to be reused, for example, to enhance the cementitious composites, or for example, for polymer. The goal, of course, is to make the cement industry able to contribute at least the 20% reduction of CO2 emission in the medium and in long term. And this is very important because, as you can see, the growth of carbon emission is an unmitigated problem. As you can see, in the period between 2000 and 2018, there were a huge increase in terms of CO2 emission, and they are related especially to the industrial and the economic growth of China and India. Probably you know that in the cement factory plants, the CO2 emissions are mostly related to the process that transform the limestone in calcium oxide via the calcination process. And this calcination process accounts for 50% of CO2 emissions. And it's important to highlight that these kind of CO2 emissions are very difficult to eliminate. The 35% of CO2 emissions are related to the burning fuels, and the remaining 15% are indirect emissions in atmosphere that are widely related to the greening phases and to the transportation of the materials out of the cement plant. Although cement is highly energy process, we are pretty sure that cement is an essential product in our building sector. And for this reason, there is a growing interest to understand if there are some new possibilities to reduce the carbon footprint of cement production. In the last decades, there were some investigation about supplementary cementitious materials, for example, silica fume or fly ashes. And in the last 5 years, there is a growing interest in alternative cementitious materials, for example, geopolymer, or manufactured cementitious materials. The mean value of these materials is the size. The nanosites play a very crucial role in the innovation of concrete technology. As you can see, if we move toward the nanometer particle size, the specific surface area increases dramatically. And this means that the particle possesses a very high specific surface area volume ratio. This means that there is a wider contact between the particles and the surrounding matrix, and this means that with a smaller quantity of materials we are able to obtain very performing cementitious materials. So after this brief introduction, I'd like to present to you the main focus of our research activity. As I said before, we started a few months ago, and our group, into the structural department of Polytechnic of Turin, work in collaboration with the Applied Science Technology Department of Polytechnic of Turin. The main goals, the main objectives are for sure the incorporation of this kind of nano calcium carbonate particles obtained via precipitation of CO2, the evaluation of the mechanical properties in terms of flexural and compressive strength, and of course the optimization of the characteristic of calcium carbonate nanoparticles according to their use in the cement-based composites. Probably I can skip the preparation of the cement mortars. We use the standard procedure that is regulated via the regulation of the European Union. And the only thing is that the proportion by mass in this investigation are 1 part of ordinary Portland cement, 3 parts of standard sand, and 1/2 part of the ionized water. In this case, we fix the water to cement ratio equal to 0.50, and the nanoparticles of calcium carbonate have been added to the cement mixture with 2 different percentages, 2% and 3% with respect to the weight of cement. We carry out a double investigation in order to understand the proper mixture design, and we investigated the solution of calcium carbonate nanoparticles mixed in water with and without the ultrasonic bath. Okay, I can skip this. The specimen are the standard mortar specimen. And we carry out the mechanical test after 7 and 28 days curing. The mechanical test activity was performed by mean the 3-point bending test and compressive test, by mean the testing machine with a load cell of 15 kilonewton. Regarding the first results, I report the histogram with the mean values In this case, for the flexural strength, with the 2% addition of calcium carbonate nanoparticles. And as you can see, in the histogram, we have indicated with gray the reference mortar, with the yellow color the mortar with 2% of calcium carbonate nanoparticles without using the ultrasonic bath, and in green the composition with 2% of nanoparticles mixed in water by means the ultrasonic bath. As you can see, the cement mortar prepared without the utilization of the ultrasonic bath gave bad results, both at 7 and at 28 days. And this is the first results because probably we need, and probably in the industrial plants, there will be need the solidification all the mixture. What is interesting is the difference in terms of 7 and 28 days, because as you can see, at 7 days, the mixture with the ultrasonic bath presents quite interesting increase in terms of flexural strength, while at 28 days this increase is totally loses. Probably these nanoparticles behave like accelerant particles, and probably they promote an early age strength. Regarding the compressive strength, the trend is absolutely similar to the previous one, but in this case we noted that the mortar prepared without the ultrasonic bath exhibit a small gain compared to the reference one. As I said before, we are now investigating other percentage. In this case, with the percentage of 3% with respect to the weight of cement, we noticed that both for flexural strength and compressive strength, there is a small decrease with respect to the same composition, but with the 2% of nanoparticles of calcium carbonate. The first very little conclusion are up to now that probably the optimal addition of this kind of particles is set on 2% with respect to the weight of cement. The ultrasonic bath is fundamental to guarantee a proper dispersion. Probably, and this will be investigated with the help of applied science technology. These particles, for their morphology and for their chemical composition, increases the early age strength of cementitious materials. Of course, these results are only the first step in order to understand the behavior of these particles and so to set the proper mix design. If you want understand more information about the project, here you can see the email, or you can contact directly the official Twitter record account. Thank you.